So this is a dynamics question. We have an object that is going to be at rest, and that means the forces have to be balanced. So I'll draw a free body diagram of it. This object has gravity pointing down, and it's got an electric field applying an electric force onto it. So the metal ball has a positive charge. Since it has a positive charge, the direction of the electric force is going to be the same as the direction of the electric field, which the diagram is showing towards the right. It's a horizontal electric force. I'll use F sub E for the electric force. So the net force needs to be 0 because it's at rest. Right now it's not at 0 by the diagram. There must be a third force, at least, to balance those out, and that would be provided by the tension, the string holding it. So I'll draw that in, and I think that would be it for the forces. So everything has to balance. I can work it out into components and have the horizontal components balance, as well as the vertical components balance. This is just not quite the scale. I'm going to redraw that a little bit, make it a little bit better. Okay, I'm going to draw in components of the tension. So I'll call one FTY and FTX. So I'll look in the y direction first. That's going all the way back to gravity. So in the vertical direction, to balance the forces, basically my y component of tension must equal to the force of gravity, the magnitude of it, which is equal to mg. Okay, so that is equal to 200 grams, so 0.200 times 9.8. That would be 1.96 newtons to 2 sig figs. Okay, so that's the y component of tension. And I can do a similar thing for the horizontal, the x component of tension. The magnitude of that will have to equal to the magnitude of the electric force, which is equal to the charge times the electric field. Okay, so gravitational force, m times g, mass times gravitational field. Electric force, q times e, charge times electric field. Very similar kinds of formulas there. All right, so the charge is 4.0 times 10 to the negative 2. No, yeah, that's the charge. The electric field is 10 newtons per coulomb. So that'll give 0.40 newtons. That's the x component of tension. So I've got the vertical and horizontal components of tension. I can find the overall tension by doing vector addition. So that's FTY 1.96. And then FTX, which is 0.40. I can go ahead and find the hypotenuse. That'll be the overall tension. So the Pythagorean theorem will do that. Let me get my calculator up, type that in. Well, that'll give me 2.0 when I round it to 2 sig figs. And the angle I can calculate as well. That'll be the inverse tangent. of opposite over adjacent. And I get 12 degrees. Okay, so therefore the tension is 2 newtons. And it's a 12-degree angle to the vertical. That's how I labeled theta. Or a 78-degree angle to the horizontal. Okay, part B. If the string snaps, what will be the acceleration? The acceleration is just the net force divided by the mass. Now, if the string snaps, we lose the tension force. We lose the tension force. So what will the net force be? Well, since the net force started at 0, if we suddenly remove this tension force, then the new net force is going to be the opposite of this tension force. It's going to be 2 newtons, 12 degrees to the vertical again, but down and to the right instead of up and to the left. Okay, so I'll repeat that. The net force started at 0, but if the string snaps and we lose the tension, the new net force is going to be basically the opposite of the tension force. So that'll be 2 newtons. It'll be 12 degrees, but it's down and to the right. I'm not sure how best to describe that. It's still to the vertical, but to the right. Just draw a little arrow. It's going to be in the opposite direction that the tension was. Divide that by the mass to get the acceleration. That would be 10, I believe, meters per second squared. 12 degrees to the vertical. Down and right. Okay, so it's going to fall, but it's not going to fall straight down. It's also going to go towards the right a bit because of the electric field. If there was no electric field, it would actually just fall at 9.8 meters per second squared. But because it's also being pushed to the right, it adds a little bit to the acceleration. It goes up to 10.